Hello everyone, welcome to another video lesson. We're on 11.3 now. We're talking about arithmetic and geometric series. So remember what arithmetic means? It means that you're adding to get from one term to the next, and geometric means that you're multiplying to get from one term to the next. And so a sequence is when we had numbers in a particular order. Now a series is when we're going to add those numbers together. So here's our formula for a series. It's an indicated sum of the terms of a sequence. So our sequence was 2, 5, 8. We added 3 every time. Now our arithmetic series is 2 plus 5 plus 8. We're going to add all of those numbers together. Same thing for our geometric sequence. We would multiply by 3 every time to get to the next term. Now what we're going to do is we're going to add these terms together and get an answer. So that's going to be our arithmetic and geometric series. We have some formulas. You guys know what all of these letters mean here in these two formulas, except for S sub n. We're throwing that one in new this lesson. S sub n just means the sum of the first n terms. So if it's the sum of the first 15 terms, there are 15 terms in the sequence, add them all up together, there's our sum. Okay? All the other letters, you know what they mean in these two formulas. We could also do some calculator work. The letter sigma, it's a Greek letter. What it means is it means the sum. So when we want to find the sum of the first however many terms, this formula is by hand and this formula is in our calculator. They get us the exact same answer. If it's geometric, this we can do by hand and this we can do in our calculator, and they get us the exact same answer. So I'll show you both of those ways in this video lesson. Let's dive in. Here's our first one. Find the sum of the first 30 terms for this series. So the first I need to ask myself is this arithmetic or is this geometric? Because that's going to affect the equation that I use. Well, how do I get from one term to the next to the next? I am adding 2. So my formula is going to be arithmetic, and this is the formula for that. The sum of the first so many terms, which in this case is going to be the first 30 terms, and is going to be 30, is given by that equation. So let's start filling in our information that we know. We want to find the sum of the first 30. That equals the number of terms that we have, so there's going to be 30 terms, so n right here is 30, times a sub 1, that's the value of our first term. Well, here's the value of my first term, it is 2, plus the value of my last term divided by 2. Well, class, I ask you this question, what's the value of my 30th term? Well, we don't know what that is. We know that this one is going to be 10, and then it's going to be 12, and then 14, but what's my 30th term? So I got to go back a couple lessons. I need to find the value of my 30th term. So before I can do this, I have to use another equation of a sub n equals a sub 1 plus n minus 1 times the common difference d. Now I could find the value of my 30th term. A sub 30 is a sub 1, which is 2, plus n minus 1, which is 30 minus 1, multiplied by the common difference, which is 2. So again here, I need to find what a sub n is so that I could put it in for this a sub n. Alright, so I'm finding a sub 30. This is the same number as 29. So 29 times 2 is 58. So 2 plus 58, which is then 60. The value of my 30th term is 60. So this number goes right in here. There's the value of my 30th term. And now I can get my answer. The sum of the first 30 terms is 30 times 62 divided by 2, because 2 plus 60 is 62. Multiply 30 times 62 and divide it by 2, and we have our answer. Our answer is 930. The value of my first 30 terms, when I add them all together, is 930. All right, there is an easier, maybe more efficient way of doing it, and that's by using the calculators that we have. So what I want you guys to do here, first let's understand this. Here's what we're going to enter into our calculator. We press math 0 to have this thing show up. Okay? And it's going to end up looking like this. And then what we're going to do is we're going to press the first term number to be added. That goes in the bottom. Then right here in the top is the last term number to be added. And then we're going to fill in this formula. This is for arithmetic. We'd obviously use this one then if it's geometric. So here's our geometric, and here is our arithmetic. All right, so let's practice with this one that we had just on the last slide. So So what we're going to do here is we want to find the value of the first 30 terms, the sum of it. So this first box is always going to be our variable, x. X goes from the first term number to be added. We want to go from the first term to the last term number to be added, which is the 30th term. We want the sum of the first 30 terms. And then into this box, we're going to fill in this information, which is the value of my first term, which is 2, plus n minus 1. N minus 1 is going to be our variable here. So we're going to leave that in as x minus 1. Because it's just easier to use x in our calculator as it is n, we're going to put in our variable for x. So our calculator is going to put values in for n and add them all up together, multiplied by the common difference, which is d. So that's going to go in for this blank. Let's all try that together. Open up your calculator, please. We're going to press math 0, and that should come up. If it does not come up just as the way you see it on my smartboard, let me know. I'm going to have to update your calculator and put that on there. So let me know if that does not show up in your calculator. So it's the summation as x goes from the first term number to be added to the 30th term number added. Then you scroll over, and in that box, we're going to put in what we just wrote on the smartboard there, which is 2 plus parenthesis x minus 1, close the parenthesis, multiplied by the common difference, which is 2. And we already know that the answer is 930, so when I press enter here, I should see 930. There you have it, 930. So there's how you can do it either way. We'll be doing both of those when we get to other problems here in our notes for today. So let's try the next one. Use the first 50 positive odd integers to write a series in sigma notation, and then to obviously find it as well. So sigma notation is right here. So we want as n goes from the first term to the first 50. So from the first to the 50th. So now if we're thinking about this logically, the first 50 odd integers is like 1 plus 3 plus 5 plus 7 plus 9 dot 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 dot. So when we're looking at this one, this is going to be an arithmetic. So if it's arithmetic, we're going to be using this one right here, the one that we just used on the last slide. So it's going to be a sub 1, the value of my first term, the first odd integer is 1, plus x minus 1 multiplied by the common difference. My common difference is 2. Why don't you guys practice putting this into your calculator right now? Enter it just as I have it written, except instead of n minus 1, put x equals 1. And try that on your calculator. And you should get the answer 2,500. If you add up 1 plus 3 plus 5 plus 7, the first 50 odd integers, it'll be 2,500. Now let's practice using our other formula. So our other formula is this one. S sub n equals n times the quantity a sub 1 plus a sub n divided by 2. Sorry about that. Okay, so we want to find the sum of the first 50 odd integers if 50 is multiplied by the first odd integer plus the value of my last odd integer divided by 2. So again, what is the value of my last odd integer? I have to find that. A sub n equals a sub 1 plus n minus 1 multiplied by the common difference d. So a sub 1 is 1, plus the number of terms is 50 minus 1 times the common difference, which is 2. So we're finding the value of my last term by using a formula that we used 2 days ago. 49 times 2 is 98. So 1 plus 98, the value of my last term is 99. So 99 goes right in there. And now we could simply solve this using our calculators. 1 plus 99 is 100. So 50 times 100, which is 5,000, divided by 2 is 2,500. Whether you use your calculator or whether you do it by hand, you get the exact same answer of 2,500. All right, let's try another one. This time, we want to find the first term. So we want to find a sub 1, for which the sum of the first 8 terms, so we know that 765 is the sum of the first 8, and the common ratio is 2. So it tells us that it's geometric, so you're not going to be looking at the arithmetic sequences anymore. It's now geometric. So here is our formula. Let's start entering in our information. 765 is the sum of the first 8 terms. So that equals the value of my first term. I don't know what it is. That's what I'm trying to find. Times 1 minus the raised, or the common ratio, which is 2 raised to the nth power. How many terms are there? There are 8 terms. All of that divided by 1 minus the common ratio, which is 2. And now we're solving this equation using algebra. So this number right here equals a negative 1. So if I cross multiply this, I would get a negative 765. That equals a sub 1 multiplied by 1 minus, well, 2 raised to the 8th. I can do that in my calculator and get 256. So now I'm looking at this. And 1 minus 256 is a negative 255. So a sub 1 times a negative 255, that equals a negative 765. So what is the value of my first term? Let's divide both sides by a negative 255, and there we have it. When you take a negative 765 divided by a negative 255, you get the number 3. The value of my first term is 3. Okay, number 4 is going to throw a little wrinkle in things. Pay very close attention here. Find the sum of this series. I got to ask myself the question, is this arithmetic or geometric? How am I going from here to here to here? I am multiplying, am I not? By a negative 3. So this is going to be geometric. So I am going to be using this formula. Okay? So for the sum of the first how many terms, I got to use this formula. So I want to find the sum. This is my variable, S sub n. That equals the value of my first term. I know that one. It's 2. Minus the rate, or the common ratio, which we said was a negative 3. Oh, I forgot a 1 in there. Okay, so it's 2 times 1 minus the common ratio, which is a negative 3, raised to the nth. Alright, I got to find how many terms there are to find the sum. So there's 1, 2, 3, 4. I don't know how many terms there are. So I have to find how many terms there are. So I'm not ready for this equation yet because there's still more information that I need. To find how many terms there are, I got to use my geometric sequence formula, which is a sub n equals a sub 1 times the ratio raised to the n minus 1. I know the value of my last term. It's 118,098. So 118,098, that equals a sub 1 times the ratio, which is a negative 3, raised to the n minus 1. And I know what a sub 1 is. Sorry about that. The value of my first term is 2. So now I have to solve for n, because once I solve for n, I can put it in right here. All right. Let's divide both sides by 2. When I divide both sides by 2, I get 59,049. That equals a negative 3 raised to the n minus 1. So now, class, what do you do when you have to solve for an exponent up here? You're going to get common bases. So pause the video and see if you can find how do you get 59,049 to be a base of a negative 3. Try to do that in your calculator. You should get negative 3 raised to the 10th. That gives you 59,049. That equals a negative 3 raised to the n minus 1. Now you have base 3, base 3. You can set 10 equal to n minus 1. So n is 11. Your last term that you're adding is the 11th term. This is the 11th term of the sequence. So putting it back into this formula, we're right here at n. Our ratio is a negative 3 raised to the nth power, and n is 11. All of that is divided by 1 minus the common ratio. 1 minus a negative 3. Now we can find the sum of the first 11 terms. The sum of the first 11 terms is 2 times 1 minus a negative 3 raised to the 11th. So you have to follow order of operations. So you have to do this first. A negative 3 raised to the 11th. A negative 3 raised to the 11th power is this. and it is 1 minus that. 1 minus this that goes in the parentheses. So that'd be 1 plus that. So 177,148. My parentheses here now is 177,148. And all of that is divided by 1 minus minus 3, which is 1 plus 3 equals 4. So do that in your calculator. 2 times 177,148 divided by 4. The sum of your first 11 terms is this: 88,574. Whew! All right, let's try this one more time. This time, let's use our sigma notation. So this is going to be our formula. I'll rewrite it down here so it's slightly less messy. It's going to be the summation. It's geometric, so it's as my x goes from my first term to be added to my last term to be added, which we found is the 11th term. So as it goes from first to the 11th, of the value of my first term, which the value of my first term is 2, times the common ratio, which is a negative 3, raised to the n minus 1, or in this case, it's going to be x minus 1. Let's all put this into our calculator, shall we? Math, 0. As x goes from the first term to the 11th term of the first term, which is 2, multiplied by the common ratio, which is a negative 3, raised to the x minus 1. We already know that the answer should be 88,574. Let's see if we get it this way. Whoa! I must have did something wrong here. Oh, I put 111 right here, didn't I? Whoo! That's a lot. Okay, not 111, just 11. Let's try that again. Math, 0. As x goes from the first term to the 11th term, how's that better? All right, of 2 multiplied by a negative 3 raised to the x minus 1. As I was saying, we know that the answer should be 88,574. There we go, 88,574. All right, let's try another one. These are difficult, but the more practice we get, obviously, the better we get at them. 88,574. Here's our next one. Find the sum of a geometric series for which the first term we already know, the nth term is 6, and the common difference is a negative 1/6. So I already know what formula I need. The sum for a geometric series is that one right there. So I want to find the sum. I want to find this. So S sub n, that equals the value of my first term. All right, I know what that is. It's 7776. Multiplied by 1 minus the ratio. I know what the ratio is. The ratio is a negative 1/6. Raised to the nth power. Do I know how many terms there are? At this point, I do not know how many terms there are. It doesn't tell me. So again, I have to find this n right here. So I'm going to use the geometric sequence formula, which is a sub n equals a sub 1 times the ratio raised to the n minus 1. So the value of my last term, I do know what that is. A sub n is 6. So I can put that in to the left side of the geometric sequence formula. So 6 equals the value of my first term, 7776, times the ratio, which is, what is it again? Negative 1/6, sorry, raised to the n minus 1. Okay, very similar to the last one, I now have to solve for n. Let's divide by 7776, divide by 7776, and I get the fraction 1 over 1296. That equals a negative 1/6 raised to the n minus 1. So now, class, I'm going to have to get common bases again. So you guys start in your calculator, pause the video, try to get this number right here to be a base of a negative 1/6. A negative 1/6 raised to what power gives 1 over 1296. After you try that on your own, you should have got the number 4. A negative 1/6 raised to the 4th power is 1 over 1296. So that equals a negative 1/6 raised to the n minus 1. So negative 1/6 base, negative 1/6 base. I can set my exponents equal to each other. 4 equals n minus 1. So n has to equal 5 then. There are 5 terms in this sequence. So that means that this n right here is 5. All of that is divided by 1 minus the rate. So 1 minus a minus 1/6. Okay, now all this work isn't so hard algebraically, but it does get kind of messy. You got to follow order of operations. So you got to take a negative 1/6 and raise it to the 5th power. When you do that in your calculator, a negative 1/6 raised to the 5th, a negative 1/6 raised to the 5th is that number. And then we got to take 1. It is 1 minus that. So we got to take 1, subtract this number. And we get 7777 over 7776. So that's what's in our parentheses. 7,776 multiplied by our parentheses, which is 7777 over 7776. That's what we just did. Is divided by 1 minus a minus 1/6 is plus, which would then be 7/6. So we can now do the rest in our calculator. 7,776. 7,776 is multiplied by this fraction, and I get this, and then I have to divide it by 7/6. Divided by 7, oopsies, parentheses, 7/6. And there we have it. 6,666 is my answer. That's the sum of the first 5 terms. The sum of the first 5 terms is 6,666. Let's try that one more time now using our graphing calculator. So it's math 0 as x goes from the first term to the 5th term. We want to add up the first 5 terms. The first term is 7,776 multiplied by the common ratio, which is a negative 1/6 raised to the x minus 1. You guys can try to put that in your calculator on your own. Once you do that, you should get 6,666. Maybe I will put it in with you one more time so you could see it done if you're having trouble. So math 0. Then you're going to put in as x goes from the first term added to the 5th term added. Of the value of the first term, which is 7776, multiplied by the common ratio, which we said was a negative 1/6, raise that to the x minus 1. When I press enter, I should see 66666. And there it is. All right, it's a tough lesson. Let me know if you have any questions on that when you get to class the next day.